Okay, introduction to matrices. We'll talk about the RC cola here in a minute, or really pretty quick. A matrix is a rectangular array. Array is just like a fancy word for like an organized set of numbers. An organized set of numbers written within brackets. And computer science stuff, it's a great way to store information, to store lots of information, is in matrices. So there really are lots of real-world applications of matrices. Today we're not going to get those. Today we just need kind of the background of what a matrix is. And then Friday we'll do some real-world stuff with calculators, so at least there's something. When we give the dimensions of a matrix, the dimensions, plural, is always rows by column. Row by column, rows by columns. How many rows there are, how many columns there are. Hence the picture of the RC cola over there. Row column. Whoever invented RC cola was a fan of matrices. I'm certain that's why it's named that. I don't know. Probably the guy's initials. I don't know. Columns. Some of you have columns out front of your house. The White House has columns out front, right? The columns are the things that look like this. Those are columns. Right? So this matrix has 2 columns. And when you go to the auditorium or you go to a concert and you sit in rows, so this one has 1, 2, 3 rows. So 3 rows, 2 columns. This is a 3 by 2 matrix. Okay, so number 1, what is the dimensions of that matrix? Well, you pretty much got 2 choices here. It's either a 1 by 3 or a 3 by 1. Which one is it? Let's see, rows come first. How many rows are there? I think there's 1 row and 3 columns, so that's a 1 by 3. Why don't you try the next 2 while I pick on people for the next 2. Yeah, Ben, you already went today, so you're in the clear. Brooklyn, I can narrow it down. It's definitely either a 3 by 2 or a 2 by 3.
It's a 2 by 3.
It's a 2 by 3. There's 2 rows and 3 columns, so 2 by 3. Row by column. Ava, it's either a 1 by 4 or a 4 by 1.
4 by 1.
4 by 1. Yeah, I guess that one's pretty easy because that definitely looks like a column, a singular column. So 4 by 1. Rows by column. RC cola. All right, you can perform operations with matrices such as addition and subtraction. However, the dimensions must be the same. And the result will be the same dimensions. Result. So if I add, it's easy when they're square, right? You can get row and column backwards and it won't matter. So I can add a 2 by 2 and a 2 by 2, and that means my answer should be a 2 by 2. And how you add them, I always figured is like you add them how you think you would add them. You're just going to add them like by position. So 3 plus negative 9, top left plus top left goes top left. And top right plus top right goes top right. Let's see if I run out of colors. Bottom left plus bottom left goes bottom left. 11. And I got a blue, but blue's kind of dark. I guess I'll just underline it. Bottom right plus equals bottom right. -4. Careful with the minus sign. I'll do the first one and I'll let you finish it off. Top left minus top left. What's that going to be?
Minus for the negatives.
Yep.
So that's going to be 4.
So that's going to be -4. Because it's -6 plus 2 is -4.
I'm so tired.
Tricky, you got to be careful. Mason, you get an easy one, I think. 7. 9 minus 2 is 7. And George, 0 minus 8 is what was that? -8. 0 minus 8 is -8. Negative, yes. The negatives there, you got to be careful because you got to make sure it goes to everybody, and then you got to worry about 2 negatives make a positive and all that stuff. Okay, there is a type of matrix multiplication called scalar multiplication. This occurs when a matrix is multiplied by a constant. Any guesses on what we would do with that -3?
We multiply -3 by all of them.
Yeah. I don't know if distribute is the perfect word for that because that usually has some other math meaning, but yes, -3 goes to everybody. So, no highlighters needed here. -45, +36, -30, 0. Just be careful. People draw gets a little overkill with all the lines for the distribution, but -60, 30, -21, -3. So, adding works like you think it would, subtracting works like you think it would, multiplying, at least scalar multiplication, works like you think it would. There's also matrix multiplication that we're not going to do, that it's more complicated. Just leave it at that. We're in the matrix, yes we are. We should watch the movie, right? Take a day and 2a plus 3b. So let's see, if I want 2a plus 3b, I think I need to show some steps on this guy, because that's a lot of work in my head. In fact, I'm going to write out 2a plus 3b. And some of you are going to be brave enough to try to go straight to the answer from there. I think it would be wiser, certainly on our first pass at this stuff, to distribute the 2 to everybody, distribute the 3 to everybody, and then add the matrices. I think that would be a safer way to go. So if I distribute the 2 to everybody, let's see, let's pick on people. Goodness, I could pick all kinds of combinations of things. OCN, how about just tell me that entire first matrix? What's the top row? So you got to multiply by 2 4 times. Yep. Lisa, how about the?
-3, 0, 9,
Yep. And then our final matrix. Oh, let's pick 4 people because why not? Haley, Geo, Scarlett, and Aiden. Tell which one I want you to do. Haley, how about top left plus top left? -9. Scarlett, top right plus top right. Geo, bottom left plus bottom left. And Aiden, bottom right plus bottom right. Negative 12. Again, could you have done that without skipping the middle step? Maybe, if you were super careful, right? Because that'd be negative 6 and negative 3 make negative 9. And 6 plus 0 is 6. So yeah, you might could have done it without showing that step, but probably safer to show it. Okay, now for the back. Grab the calculator soon enough. 5 full fare bus tickets and 1 half fare ticket cost $90.75. 4 full fare tickets and 2 half fare tickets cost $82.50. How much does a full fare ticket cost? Well, this looks like a system of equations problem. So let's turn that first statement into an equation. 5 fulls plus 1 half, not like 0.5, but like 1 half fare ticket.
So F and H.
So yeah, I like it. Let's call that the full fares we'll call F, and the half fares we'll call H. I like those variables. I like picking variables that stick with the problem. Some people go X and Y every single time, but then you got to be careful about who's X and who's Y. If you pick the variables to match the equation, then we'll always know that F is the full fare and H is the half fare.
Why did they choose X and Y?
Why did they choose X and Y? Oh, it won't matter. I'll show you why in a minute, though.
Try to reference that to something else.
So, how do I write this first sentence as an equation? 5 F's and 1 H cost $90.75. I don't know if I want to pick on somebody yet or not. 5 F's plus 1 H equals $90.75. I will pick on someone for the second one. 4 fulls and 2 H's cost $82.50. So, Fernando, can you write the second sentence as an equation?
Is it 4F plus 2H equals 82.5?
Yep. 4F's plus 2H equals $82.50. Okay, there's our system of equations. We know how to solve that. Like if we were going to solve this by hand, I'd multiply the top one by -2 so that I can combine them and figure out what F is and then work backwards. But we're going to learn how to do it with a matrix. You can write this or these 2 equations as one matrix equation. All you have to do is grab the coefficients, as long as everything's neat and in order. Right, there's the 5 and the 4 and the 1 and the 2. 5 and 4, 1 and 2. And then your next column matrix is the variables. And then there's your answers. And in a moment, we're going to use the calculator to solve that for us.
Do we have to memorize the vocabulary for that?
To memorize the vocabulary.
Like,
No, you don't have to memorize the vocabulary as long as, and it's pretty easy to see, right? Like the matrix looks pretty similar to those equations, right? It's like you just remove the variables and there's 5, 1, 4, 2.
how could I trust that? It's a matrix.
And so it looks very similar to what, like your system that you wrote, right? Just click off the coefficients to make the square matrix, and then use your variables, and then the answers.
Does it matter which ones are on top?
It would not matter. Like if you had wrote these in a different order, it wouldn't matter. Your matrices would look different, but you'd still get the same answer. Okay, so what we've got is matrix A times matrix X equals matrix B. And we're trying to get X by itself because we want to solve for X. So normally if you had, let's work out like a super simple problem here. If I had 5 times X equals 20, and X wasn't a matrix, X was just a number, what would you do to solve for X? Divide by 5. And you'd get X equals 4. Thank you, sir. But here's the trick. How will you do that? Because you can't divide matrices. So I can't just do, well, let's just divide by matrix A, because you can't divide with matrices. So let's back up to our problem over here. If I had 5x equals 20, and I told you you weren't allowed to divide, what could you multiply by?
1 over 5.
You could multiply by 1 over 5. Now, in number world, there's no difference between dividing by 5 and multiplying by 1/5. But in matrix land, there is. So we're not going to divide. We're going to multiply by, and maybe this looks familiar, 5 is, or 1/5. If we raised 5 to the negative 1, it would be 1/5. So we're going to multiply both sides by a to the negative 1, the inverse of a. Those will cancel each other out. And there's our answer, A inverse times B. Now, we need a calculator to figure that out. But let's set up number 1, and then we'll get the calculators and talk about how to punch the buttons. Okay, so number 1. Solve the system of 2 equations using matrices. Here's what we'll ask on the test. Show the matrix equation. So do not go straight into the calculator. We want you to show the matrix equation. Now, when they're all set up nice and neat, it's pretty easy because all you have to do is pick off the coefficients. 2 and 3. Uh-oh, what's the coefficient of the x in the second equation? 1. 1 and 2. And then the variables in order, x and y, equals 11/6.
What do we have to put x and y there?
Because that's part of the equation.
Oh, because 2. Wait. Why is it like that?
Why are they like going down rather than going across?
Like, I would think like for the x it would be.
So it looks confusing because, and this is why sometimes we teach matrix multiplication by hand, because this makes sense. But if you're multiplying matrices by hand, we don't have to know this, but this will help make sense of what's going on here. You do row times column. So you would do 2 times x plus 3 times y equals 11. So you do row times column. 2 times x plus 3 times y equals 11. Or the next row would be 1 times x plus 2 times y equals 6. That's why those variables look weird, Ben. Did that kind of answer your question? Okay, well now we need to grab a calculator to put that in for A, that in for B, and we know our answer is going to be A inverse times B. Okay, so I need you to grab a calculator. See if I remember it. So what button looks like a good button to push if we want to work with matrices?
Second.
See anything on there that might be a good choice? The word matrix is on there. So toward the top left, let's go second matrix. And thank you for staying with me. Don't jump ahead, because then you're going to get lost, and we're going to have to, so stay with me on this. What we want to do first, like those are just the names of them, we want to edit a matrix. We want to put some information into the matrix. So let's edit, and then you can pick which name you want, but I would suggest A and B because that's what I'll be using the whole time. So let's edit matrix A. Sometimes we get confused on sizes, but what's the size of matrix A?
Wait, yeah.
Whoops, do I need to back up?
Oh, just enter B. Yeah, never mind.
So matrix, ooh, that's not what I want. Matrix, edit A, so enter. What size is matrix A? 2 by 2. Right, it's nice when it's a square. It's hard to mess up a square. So you put in 2 by 2, and it automatically builds a 2 by 2 matrix ready for you to put the numbers in. So 2 and 3 and 1 and 2. Be careful on that very last number. If you hit escape, like if you get out of that before you press enter, like, so I'm telling it that I want element 2 to be 2, but it's not 2 yet. So either press enter or press an arrow to move things around, and then double check to make sure your matrix is 2, 3, 1, 2. Right? Your calculator's not going to mess anything up. It's only going to be if you type the matrix in wrong. Question, Kinley? Brooklyn, did you have a question?
Bottom left. Oh, 1.
All right, so I'm putting in matrix A into the calculator.
No, oh my gosh.
By the way, you Inspire people,
Is this correct?
your matrix button is yep. All right. Your matrix button is right there.
This is the
And then you can figure it out from there. Okay, matrix A is in. Let's exit. So second quit, get out of that. And then we're going to do matrix B. Finley? Well, that's what element it is. That's like the name of the element. 1, 1, 1, 2, 2, 1, 2, 2. But you can see where it is on the calculator, so you don't have to know which one we're talking about. By the way, that's also R, comma, C. So everything's RC. Okay, I need to do the same thing with matrix B. So same steps, second matrix. I want to edit a matrix. But now I want to edit matrix B. So enter on B. And let's say you forgot if this was a 2 by 1 or a 1 by 2. So I don't know, is it a 1 by 2? Type in 1 by 2, and does that look right? No. So you're like, whoops, I guess it's a 2 by 1. So even if you mess up the dimensions on this, the calculator will show you your mistake. So 2 by 1, yeah, there's 2 rows, 1 column. 11 for the first one, 6 for the second one. And again, make sure that they're both in there.
Where are you supposed to do?
Go ahead.
I think I did matrix B first on that. How do I fix that?
So go to matrix A and edit it into the right one, and then go to matrix B and edit it.
Yeah, but what do you do when you have this?
Okay, hold on a second. All right, has everybody got A and B in their calculator?
Wait, A and B.
Well, you're not doing A and B. You're just typing in the matrices. What I want now is A inverse times B. So I want to go get matrix A, do its inverse, and then go get matrix B. So again with the matrix button. Now I don't want to edit it. It's already edited. I want to use it. So under names, I'm just going to press enter, and that's going to put matrix A like back on the home screen. There's matrix A. And there's a little button that means -1. It's the little button that says -1. So on the left-hand side, so there's A to the -1. And then times,
Wait, so we put -1?
you'll need to put -1. If you're on the Inspire, after you type in matrix A, do the -1. And now I need to go get matrix B. So same steps, second matrix, scroll down to matrix B because I want to use matrix B.
And then it also multiplies with the matrix B.
And then A inverse times B. There's my X and Y.
least for matrix. What he said.
Hold on a second. Now, I don't want your answer like that. I want your answer as an ordered pair. So 4, 1, like that.
What is B?
Matrix B is this column matrix 11, 6.
Oh, 11, 6.
Aiden, you good over there?
Yeah. 11.
Max, you good? Once you've entered one in, you do second quit, and that gets you back to the main screen.
I got 4 and 14.
I don't know how quickly I can do this on the... So, matrix... 2, 11, 6. Uh-oh. 1, 2. I don't know why that didn't work.
At least it's settings of the calculator.
Again. Did yours work?
No, it said false.
False. You got something with an angle in it. So, I don't know. I'll look at those in a minute.
There's a menu option to go to matrix, not that button.
Okay. So the menu option will get you there.
Menu 7, or no, 7, 1.
Oh, man. Oh, yeah. But there's the matrix button right here.
But that matrix button isn't working, so I don't know. That's why I'm working with the 84s. Okay, has everybody got 4-1? At least if you got an 84 on you. All right, let's try number 2. You remember how hard this was, a 3x3 by hand? Well, the calculator is going to do it all at once. And it's super easy to set it up. A, X, B. X equals A inverse times B. So why don't you see if you could do number 2? Put a big one in for A, the small one in for B, and then A inverse times B.
I think inspired became.
Look at today's assignment is this worksheet. Number 1, super easy, as long as you can subtract integers. Let's see. This first one is a column matrix. It's 3 by 1. The next one is a column matrix. Is 4 by 1. And I'm supposed to add by position, but they're different sizes. Read the directions and see if you think you can come up with an answer. It's it is undefined. You can't add matrices that are different sizes.
There's something wrong with my calculator. You just have a calculator that works. Because it works for you, though.